Hello, hello. How's everyone doing today? We're back at it with Chicago Roboto. Today I'm at a coffee shop, so I guess we're just going to continue with this Chicago experience bit. All right. Without further ado, we have Zac Sweers and James Barr in Lessons from a Librarian. Just a couple notes. Below, you should see a hashtag for day 2, Zac Sweers, James Barr. That's where you can ask questions. Feel free to ask throughout, and we'll have a Q&A at the end of the session. And of course, don't forget to say hello to your sponsors. I believe we just posted a link, both in, I believe, in announcements for how you can do that. All right. Thank you so much, and feel free to take it away.
Cool. Hi, I'm Zac Sweers.
And I'm James Barr.
And we have been librarians in large code bases for a number of years, and we wanted to kind of share some of the lessons that we've learned in that time with you all today. These should be generally applicable regardless of the size of the code base, and I hope you enjoy. If you want to follow along with the slides, you can find them at this link. We've got a little progress bar to help us stall time long enough in case anyone wants to copy it. Or actually, since we have the Slack, James, if you want to paste that in the channel for our talk, that'd be good. Yeah, so let's look at an example. This is a little bit of a story from one experience that James and I had working at Uber together. Say you have a subscribe method. We use it for ArcsJava. The ArcsJava part of that is not really the most important, but what you need to know about it is that it takes a callback. In this case, just a consumer. It's a single abstract method, very simple stuff. Now, years ago at Uber, we had this problem with error handling. People would use this code not knowing that if there was an error coming down from upstream, that it would crash the app. And to try to resolve this, we basically took a really heavy-handed approach and banned its usage and introduced it with something more descriptive. Clever naming aside, the custom class. This basically worked as a custom class. It was abstract, only had one method. It was very easy to use because the IDE would automatically implement everything for you. And the other goal here was to have this help with stack traces so we could try to find where the subscribe method was called whenever we did get a crash. So several years later, this was all over the code base and used ubiquitously. We had Java 8 lambdas now through tools originally Retro Lambda and then later Dsugar. But we couldn't use them yet because these were all abstract classes and not functional interfaces. It also turned out that everyone just used these because a linter told them to, and not necessarily because they were thinking more about the crash nature of it. So it wasn't accomplishing the original goal, and it was annoying. So we circled back and reevaluated things. And long story short here is that we figured out another way to do the stack trace tagging. They worked passively without needing a custom subscriber class. So we could move off of requiring this and allow people to use lambdas now, and everyone's happy. We ended up open sourcing this as a library called arcsdogtag later, and this is cool. But we still had a bunch of what's now tech debt, like literally just thousands and thousands of use cases that in most code bases, this really just becomes forever debt. And for us, we migrated them all in a couple of days across the entire code base with no regressions and no formatting issues. But how, you might be wondering, how exactly does one safely yeet thousands of files of tech debt out of the code base at once without any sort of repercussions? And that's what we'd like to talk to you about today. So a couple of years ago, Jesse Wilson from Square gave a great talk called Writing Code That Lasts Forever. And we're going to talk about a lot of similar things, but more about code that other people write. So not just your own code, but helping everyone write code that lasts forever.
So a great way to help others write better code is to already have many examples of good code in your code base for them to learn from. But what exactly is good code? Well, that's ultimately up to you. A minimum bar for code quality might include such things as code that builds quickly, is sufficiently tested, and is well documented. On the other hand, some things that might detract from code quality could be duplicated code, using deprecated APIs, and not modularizing your code. Since it's difficult to come up with an initial criteria to start out with, I recommend you begin with something less controversial and refine your definition over time. Then, once you select your initial set of criteria, you can audit the health of your code base and collect data for each of the metrics. Ideally, you can do this with an automated process, such as a CI job or a periodic task, to make this do the work for you. But once you do this, this allows you to create graphs and track the quality of your code base over time, even alerting on major regressions that come up. Then, in order to quickly summarize the health of your code base, consider creating your own quality score. This would be some combination of the metrics weighted more heavily towards the criteria that you find to be important. The score also provides a way for you to set an overall goal for the quality of your code base.
So now that you've got a report card set up, let's talk a little bit more about this tech debt and how it accumulates. So fixing is one thing, obviously, but prevention is ideally better. So your first line of defense here is going to be enforcing good API design in your code base from the get-go. You can't really misuse what can't be misused, and that's sort of the guiding principle here. And we could talk about this really all day, or at least I could talk about it. James probably wants to move on. But let's go through some principles of this. These aren't hard rules or anything. They're just guidelines that you can keep in mind when writing new code. So one of the easiest ways is limiting API surface area. And now this is a bit multifaceted, but we can jump through a few small examples here. So one is, say you've got a hammer. Do you anticipate it being used for anything other than being a hammer? No? Cool, make it final. In fact, you should make it final by default. Kotlin really helps you out here as well, because that's how the entire language works. There's some other things in here. Visibility is a big one. This is a place where Kotlin doesn't help you out of the box because it's public by default. But basically, you want to start with private, move up through package, internal, protected, etc. In Kotlin 1.4, they have a new explicit API mode that is really handy for library authors that does make you explicitly declare if something's going to be public so you don't accidentally ship a wider API than you anticipated. And lastly, factories. So factories can often replace constructors with more meaningful names and also allow you to have a finer grain of control over how an object is instantiated rather than having to hand over the constructor directly, which can always only return that specific class that you're instantiating. This allows for later changes down the line, allows for factoring without changing anything in your public API. And this can best be summarized in this tweet that I had a couple years ago, where basically when I first joined Platform, I thought, oh, we'll just skip final because then it's nice for Mockito users. And then after a couple of years of that, we realized that that was a terrible idea, and the whole thing was a dumpster fire, and we never wanted to make anything not final again. Next, I want to talk about consuming interfaces. So everyone's familiar with the composition over inheritance side of it. This is kind of related in the sense that I like to, when working on a library, have a public API defined as an interface, and then have all of your tests deal only with that interface. It provides a lot of flexibility for users so that they can provide their own implementations. It also allows you to better hide implementation details. And I think most importantly, it keeps your tests really honest, because if you can't verify correct behavior of the thing that you're using from the public API alone, then neither can any of your users. I think I've lost a slide in here. That's embarrassing. So basically, at the end of all this, you want to kind of ask yourself, how easy is it to do the wrong thing, and at the same time try to balance that with how is this going to limit me later. Two more things in the API space I want to talk about, but at a more macro level. The first is API versus implementation. Now, this isn't a new concept to most of you probably, but you can enforce this at a actual project level. So let's look at our hammer again here. Right now, it's just under, we'll say, a hammer project. And we might have other projects down the line that are using hammer and nail, libraries, and then ultimately moving up into our application at the top of the project graph. Now, this hammer might be passed in through dependency injection up to the app, but every time we recompile the hammer, we're finding that this is going to recompile everything, even if its public API hasn't necessarily changed. Gradle has some machinery for this on the Java side. If you're using Kotlin, it's, we'll say, less so. So another approach that I really like for this is actually completely separating API and implementation modules. So you can pull out your API, you can make your Hammer module just depend on that and implement that API. And then you can restitch your dependencies nicely so that whenever you change an implementation detail about your Hammer, the only thing that's changing is the app at the top of the graph that we know at runtime is ultimately going to pass down this real instance to the libraries that are consuming it, but we're avoiding the entire compilation pipeline of this along the way. The last API change I want to mention in here, or API space, is talking about build config. So build config in Android is just this class of static constants in your app, and it also gets generated per project. We can actually use the previous pattern that we just talked about to generate only one and make it more testable. So right now, it's constants, but what if we extract an API out of this? Now you've got an API interface, you can stick that into its own project, and your app can basically just implement this, back it with your build config constants under the hood, and pass this down to anyone that needs a build config information. Better yet, do you really even need this in the app module? How often does this build config change? Instead, what you could do is take it, stick it in an implementation class, do the restitching, and we've got the same sort of compilation avoidance that we had before. And the last note on this is I highly recommend this. It's on by default, and you should really just only enable it in the one module that actually needs to reference it directly. So in particular, it means disable it in all of your libraries. You'll do yourself a huge favor. Please do this. If you take nothing else away, just disable build config in your libraries. Some more resources here. API design as an art is a talk that I gave a few years ago about this. There's Jesse Wilson's Writing Code That Lasts Forever talk. Effective Java, the book, is always a great resource for this kinds of stuff. And also a link to an example of this app build config pattern. Next thing is code review. So code review is really the most refined tool in your belt. It's what's always going to get you the best result, but it's also the most expensive. So it really doesn't scale for repetitive things, and you should really keep them focused on finding solutions rather than doing things that could really be automated. So as such, you want to make sure that you're not wasting that time on bike shedding, which leads us to static analysis, because you can't bike shed with a linter. So static analysis is really essential, no matter how big your code base or your team is, but especially as both of those get larger. Sometimes it's preemptive, and sometimes it's retroactive. And we'll see examples of this. The two main types that we like to use that I'm not going to really dive into here, though, are lint and error prone.
So after you've set up your new API and static analysis, it's time to refactor your code base in order to reduce your overall tech debt. Let's take a look at some of the tools that we have available to us. To start off with, simple refactors can just be done with find and replace. This can be done in IntelliJ or even any other text editor. These editors have directory and file type filters and even regex support for more complex replacements. On larger projects, you'll probably get better performance if you work in the terminal. Using tools like find, xargs, and sed will help you work faster when you're modifying thousands of files and avoid freezing your IDE. When you're working in Kotlin code, there's a useful feature for deprecations. This deprecated annotation signals that an older API should no longer be used, but it also allows you to provide a hint to the IDE. This hint is then used to signal to the IDE that a replacement is available, which can be made locally or even throughout the entire project. Another nice way to suggest code changes to engineers is with Android Lint. It's a nice choice because it analyzes Java, Kotlin, and XML resources. These suggested fixes show up in the IDE to give engineers fast feedback and quick resolution without even needing to run a build. Now, structural find and replace is just like the regular version, but with added code intelligence. It's especially useful when you're trying to migrate code that can't be easily distinguished with just a regex. IntelliJ has a wide variety of templates built in to start off with. This particular example was based off of the method call template. Instead of just entering plain text or a regex, it uses variables to represent parts of the abstract syntax tree, like instances, method calls, or parameter lists. You can then configure the properties of these variables, like type or count, in order to refine what you're searching for. This example on the slide, this was actually how we did the migration for the crash on error consumer to Lambda migration that Zach mentioned at the beginning of the talk. Now, right now, this is only supported in Java code, but if you follow along on the ticket at the bottom of this slide, for example, for updates on Kotlin support, you can see that it's actually in beta. Now, IntelliJ is pretty powerful already, but if you need even more control, then you can create your own IntelliJ plugin. I mean, don't you sometimes wish there was a built-in option in IntelliJ just to remove Hungarian notation? Well, with a plugin, you can add your own refactor tools. A plugin would help you invoke IntelliJ's refactoring tools programmatically, which is useful when you need to do multiple operations like renames or structural replaces. At Uber, we built a plugin that ran many structural find and replaces in order to migrate AssertJ over to Google Truth test APIs. And you can see a link at the bottom of the slide for a similar script. If you need even more customization, though, you might consider using a scripting language like Python or even Kotlin to transform your source files. This is really good for doing transformations based on output from another tool, such as a test failure report or a lint error report. We were able to use this method to perform our Android X upgrade because we didn't have the tool available to us because we don't use Gradle. Now, this turned out to be a very large change in our Android monorepo, but we tried to make it safe as possible using some of the stuff that Zach's going to talk about.
So automation gives you a lot of confidence, but computers can't obviously do everything for us. And not every change is big. Some are small but significant. My favorite examples of this is Play Services, where I've definitely seen cases in the past of updating it, and we can measure the rollout of Play Services by our own crash reporting. So you don't have to wait until rollout either, though, because you can use something that I like called shadow jobs. So shadow job is a silent main branch CI job that applies and incubates a new change behind the scenes. Sometimes it's there to test a new change. Sometimes it can be a sort of crystal ball into the future, allowing you to build your repo against new versions of tools that you use and have a sense for their stability. You can report bugs early, et cetera. And it allows you to really update with confidence even on day one. Some great examples of use cases for this are testing beta and canary versions of the Android Gradle plugin, testing Gradle release candidates. If you want to look at updating your JDK, Android Studio 4.2 is going to ship with JDK 11. You might want to start looking at that. Particularly around build tools areas, there's a lot of sort of release candidate mentality in the community that makes it very easy to test against these newer versions. Android X is another great place that has now started publishing snapshots. At Slack, we've been able to use this to basically update almost all of our build tools to the latest stable versions on day one when they're released. Next quick thing that I want to get through is something called offensive programming. So we all know defensive programming. Offensive is the opposite. Basically, it says you should explode early and fail quickly in debug builds. Sorry, I said that in the wrong order. You should fail quickly and explosively in debug builds, and then in production, fail silently and log there. Next, James will talk about unflaggable changes.
So when you can't feature flag the changes that you're trying to make, you should take some additional steps in order to improve the safety of the changes. The first thing you can do is actually build a copy of the app from a branch for stakeholders. That way they get a chance to test the changes before they're merged. This also reduces the chance that you'll need to revert the entire change after getting it in. Another thing you can consider is using multiple commits versus a single commit to make this change. If you do multiple commits, you'll have the chance to revert just a portion of the change, but you also might need to split up the change just to fit it through your CI pipeline, depending on your limits. On the other hand, if you have a monorepo, you might be forced to just make a single commit, no matter how large. Then, when the time comes to merge your changes, do so after a build cut or over a holiday freeze to maximize the soak time before the changes reach a production build. I mean, you don't want to thrash any other engineers with rebase conflicts right when they're trying to merge their features in before their deadlines, too. And after these changes are merged, let other people know. Email your engineering group with the task details, the commit, and rebate steps. Bonus points if they can be scripted. And since communications often get lost in large companies, also send a Slack message to your engineering room with the same information. And share the news at your weekly team meeting. And even send a carrier pigeon or a raven to that one person that never checks their messages. So wrapping up, we covered measuring tech debt, designing good APIs, reviewing code, using static analysis, refactoring code, and de-risking changes. We hope that some of these lessons that we've shared with you today will help you to keep your code base clean. Thanks.
All right, that was a super great talk and like very interesting. I actually spent like quite a few months working with like compiler plugins, and I had some teammates working with IDE plugins. That's quite amazing. We do have some questions that are coming in, so we'll just go ahead and shoot for it. And of course, if you'd like to ask questions, folks, be sure to head over to the Chicago Roboto, J2 Zac Sweers and James Barr, and prepend with a question, and I'll do my best to make sure that they are asked. Okay, so first question. Zac, since you're recommending multi-module libraries, do you have any guidance on bundling those libraries into fat jars, AARs, or publishing every module independently?
I'm not sure I understood the question. I don't know if you want to, like, when you, I'm not sure I understand.
I can try to rephrase. I think I maybe understand what they were going for. I think what they might be asking for is, okay, if we're recommending multi-module libraries, I suppose they're looking for any possible tips on being able to bundle those libraries that are using the multi-modules into, I suppose, like fat jars that maybe they want to create in their own libraries, stuff like that. I believe that's what they were. Oh, here we go. We have a little bit more. If your library is multi-module, Gradle will not bundle all modules into a single publication.
Yeah, I guess.
And then Gradle treats. Oh, sorry.
So is this specifically with regards to like the API versus implementation setup, where like both of those come together, but you want to ship them? I don't know. I guess I always basically treat every individual Gradle project as its own library, and they might have some shared dependencies like I don't know, like a runtime or common bits. But I guess the only times that I ever really run into a scenario where I've needed to fat jar something is when I want to ship like a command line tool. So, not sure how helpful that was.
We're getting some typing.
Yeah. Yep, that's
so. This answers the question. So you publish each module and subproject as its own library. Okay. Yeah, that sounds good. I actually have a question myself in regards to some of the modifications for the, the whole like translate to Hungarian or whatever. Can you expand a little bit more about the nature of like the IDE plugin work that you've been working on? What were some of the challenges?
The really nice part of it was you want to get the code intelligence that IntelliJ already has. So if you could just like double click on a variable name, hit right click, rename, and then just change that over, then ideally you would just do that. But you don't want to have to you can't do that outside of IntelliJ and search like over an entire code base, because then you lose your intelligence. But then you could almost do it with structural find and replace. That way you kind of get the benefits of code intelligence, but you kind of want to do this in multiple files and have a little bit more control than just simply like moving bits around. Like for the crash on error to Lambda migration, you're basically just taking the code block inside of the interface and moving it out into its own Lambda. But when you're renaming, the API is a little messy. So it's much easier to just then create your own plugin. That way, you're pretty much just kind of instructing IntelliJ what to do. And you just get the fine-grained control and just piggyback off of all of its smartness.
And like, where were some of like the best resources that you found for creating IDE plugins? I'm sure like a whole lot of people got excited when they saw that and they were like, oh man, I wonder if I could do it myself.
Yeah. I mean, the other nice part, just to add to that, was that you also get built-in rebasing too. Like if you just had a script you ran, then someone else would have to do that. But then if they try to merge, they get a conflict, and you just tell them, hey, just run the script before you land your huge change. And they just run the plugin too, and it's right available to them. IntelliJ on their website, you can just search for IntelliJ plugin, and they have a whole website dedicated to their plugin development kit, as well as some documentation that's actually built into IntelliJ itself. And then I believe on one of our slides about the IntelliJ plugin, you can actually kind of just start with that as a skeleton and then reuse a lot of it.
Honestly, that's my favorite way to learn.
Yeah,
start with something that works until you break it.
Exactly.
We have another question coming in. Do you run any kind of static analysis locally?
So the slide that I think I lost in the talk was actually going to mention that you should have some sort of auto formatter in place. Code formatting, that is like the single greatest bike shedding tool in history, especially if you work on Uber Eats. Sorry, James. And if you're for Java, Google Java format is great. For Kotlin, you can use KT-lint. At Uber and also now at Slack, we have them set up as commit hooks. So like you can write code in whatever format you want, and then the formatter runs during the hook, and you don't have to worry about it anymore. Unless you're on Uber Eats, in which case they will still ask you to alphabetize your fields. Other local static analysis is running detect, which is not really a formatter, although I'm sure it has a formatting option somewhere. But we run those as a commit hook as well. And then James can definitely also speak to some of the stuff that runs in Arcanist.
Yeah, Arc, which is a part of Fabricator, a similar tool to something like GitHub, has its own linters that you can add via PHP that can run various scripts like checkstyle. KT-lint is another popular one. And then ideally, when you're checking in, you're not having to fight over what the actual style guide is. It's been decided, voted on, or something. And you just submit your code, and when you actually make that PR, it'll run those checks for you before submitting.